Here's a Rayleigh Criterion problem that came from the 2010 test that we took last time, right? So a space shuttle orbits high above the surface of the Earth. It carries two panels separated by a distance of 24 meters. Right? The panels reflect light of a wavelength of 500 nanometers toward the observer on the Earth's surface. The observer views the panels with a telescope of aperture diameter 85 millimeters. The panels act as a point sources of light for the observer. So what we're saying is here are these panels, right? Right? They're 24 meters apart from each other, right? Okay. And they are 300 kilometers above, and we're watching through this little telescope like this, right? Right. So our B here is equal to 85 times 10 to the minus third meters, right? That's millimeters, right? And that's 24 meters, right? And then this angle right here, if we draw that, it's so terrible at drawing straight lines. Okay, that angle right there is going to be theta is equal to the distance here, 24 meters, right? If we assume that that's like an arc, right? 24 meters divided by 300 kilometers, right? 300 times 10 to the third meters, okay? So if you've got a circle, right? If you've got a circle and you want to know here's R, right? Here's the length there, S, the chord length or whatever that's called there, right? Theta is equal to S over R, right? Here I'm assuming that that's so close together compared to this distance that it's essentially the same length as the arc length, right? Okay. So 24 divided by 300. Oh, describe what is meant by the Rayleigh criterion. It is the minimum resolvable angle, as determined by the wavelength, and I'd write this out, and the aperture. Okay, theta equals 1.22 lambda divided by b, where lambda is the wavelength and b is the aperture. Right? Okay, and then determine whether they be resolvable. Well, okay, here's my first step here is I'm going to find out this angle, 24 divided by 3, and that's 8. This angle is equal to 8 times 10 to the minus 5th radians, right? That's what the angle really is. Now let's figure out what the Rayleigh criterion is, right? So theta equals 1.22 times 500 nanometers, so 500 E minus 9, right? Divided by, my zeros are looking like 6s. Okay, and then let's see, we're dividing by the aperture, which is 85 millimeters, so 85 E minus 3 meters, right? So this will be meters, that's meters. Definitely this is a pure number, 1.22 times 500 E minus 9 divided by 85 E minus 3. And we get 7.176 times 10 to the minus 6th radians. Okay, so that's how big the angle is. This is how much we can resolve, right? We can resolve things down to that angle. So yes, because this angle here, right? The actual angle is bigger than the Rayleigh criterion angle. Yeah, that's what I wrote. I really did write that, right? Okay. Yeah? Is that right? I hope that's the right answer. That is the right answer.